Hey folks, yeah, so I'm Craig. I'm a product guy at Google. I've been there for about 5 years. Initially worked in the infrastructure service space and built a product called Google Compute Engine, which is our VM-based offering with a number of folks that are, some of whom are in this room actually. And then went on to work a lot more on the container stuff. So I was one of the co-founders of the Kubernetes project, product manager for Google Container Engine, and I've been pretty active in this space. There's also around sort of the formulation of a lot of the standards around Cloud Native Computing Foundation. So what I'd like to talk about a little bit is just give you the story from Google's perspective. We've been in the game for a little while. As Jonathan mentioned, there's been this idea of the Type B cloud, and we've been running Type B cloud for quite some time. And the entirety of the Google business is really built around that model. I'd like to just give you a little bit of insight into how that happened, why that happened. Why did we get here? What were the kind of forces that got us to this point? I'd like to relate some of those experiences, how they kind of come back to you. Obviously, we made a lot of great decisions along the way. We also made some dubious decisions along the way. And our hope is that by bringing these technologies to you, we can help you steer your way around some of those poor choices and actually fall into the pit of success. And then what I'd like to also talk about is how to go from where we are today to actually creating a really vibrant open ecosystem around these technologies and the importance of standards, particularly Cloud Native Computing Foundation. So you've probably heard this, but Google's big into containers, right? We've been using containers to manage our applications for well over 10 years. We launch 2 billion containers a day, right? We love containers so much that our VMs run in containers. So we have containers and VMs and containers. So it's really been pretty central to our operating model for quite some time. And what it's given us is a set of really important characteristics around how we build and run and operate our data centers. It's radically simplified the management of our infrastructure. It's created radical performance and efficiency improvements by providing rich sources of resource isolation. It's allowed us to bring rich dynamic scheduling into the data center that lets us use every part of the machine that's out there. And it's really has changed the game for us in a great many ways. And I'll go into that in detail. But it wasn't always like this, right? If you go back 10 years, and we have this function at Google, which is sort of really an operations function, the SRE function. And some of those guys have been around here for quite some time. And you sit them down, and it's kind of a drinking culture. These are guys that live pretty close to the edge of disaster a lot of the time. They're constantly out there getting things working and dealing with hard issues. And you talk to them about that world prior to Borg, and they get these little twitches, and they don't really want to talk about it, and they find excuses to do something else, right? Things were really hard back then. We had these things we call success disasters that would abound. Like our applications were pretty deeply entwined in the infrastructure. And a lot of the way that we ran our world looks a lot like the way that the world runs today. And it just wasn't working for us. We were really struggling to maintain the velocity and actually deal with the incredibly aggressive growth that our internet businesses were generating. And it really forced us to step back and think about two discrete things. The first was, how do you actually get work onto a given machine? And how do you partition that machine up so that you can run a variety of workloads on it? And that forced us to really start thinking about containers and container technologies extensively. And then the second thing was like, okay, it's great that you can get it onto that machine. You can get work onto that machine. But how do you think of that machine as being part of a broader cluster? So for us, it wasn't just about the introduction of container technologies. It was also about the introduction of a more effective way to think about a pool of machines as a collective computational resource. It introduced this idea of logical computing, and it really paved the way for what we now call cloud native computing. And it's produced tremendous advantages: efficiency, sort of resource isolation, deployments are simpler, it's a lot more predictable to operate with. And so when I step back and I really think about it from the 10,000-foot view, when I think about what are the essential characteristics of this Type B cloud computing paradigm that Jonathan mentioned, what are those things? And it really comes down to these three things. One is, it is container packaged, and containers solve a really gnarly provisioning and deployment problem. They create a hermetically sealed, perfectly isolated little environment for your applications that can be deployed with all of its dependencies predictably as a binary copy operation. And it makes the configuration process relatively trivial. And that solves a lot of your operational problems right there, but it doesn't solve them all. The other two things that you really need to think about is dynamically scheduling these activities, like bringing something into your system that is smarter than you are in many ways, in terms of being able to actually watch the operating characteristics of your application, make very well-informed decisions about where to run things, how many instances to run, what the health of those instances are, how they're working together. And that allows you to achieve radically higher quality of service and efficiency without actually sacrificing pretty much anything. It's just operationally easier to deal with. It's a really neat way to do this. And then the final piece of it is moving towards microservices-oriented applications. Being able to look at your application as a set of discrete pieces that aren't tied together and sort of deeply coupled together lets you actually start pulling things apart and actually scaling your organization as much as you're scaling your applications. You can think about taking something and deciding if that thing needs to be two pieces and having a very simple way to pull them apart, and then creating opportunities to sort of specialize around the ownership of those pieces. And so what the move to microservices has done is given us the ability to operate in a far more agile fashion. It's created far more reuse because we're able to take something that starts as a basic service and then promote it into a common service that everyone uses. It lets us take something that is relatively monolithic, tear it apart into smaller pieces, and then actually grow teams around those pieces. And it supports far better organizational agility for us. And so what we got from this, and this isn't obvious. I've heard a couple of people speak about this. I think Joe has talked about this a fair bit. But this is like, I implore you to think about this. If you take one thing away from this presentation, take this away from it, which is one of the most powerful things you can do, and one of the most powerful things we're starting to see, is the ability to create a specialization of operations. DevOps is really nice. It's solved a lot of problems. But what it's done is it's given your developer two sets of tools they have to deal with. There's one programming language which they're using to actually express the business logic that is the core part of their job. It's the way that you're actually solving your business problems. And then you're giving them another set of languages or tools or capabilities that they need to actually take that and deploy it out into a production environment. And you're asking them to do both of those functions. The reality is, in a lot of these internet companies like Google, we've actually created a specialized set of operational roles, where instead of giving the developer some open-ended tools that are pretty sharp-edged and asking them to actually own holistically the end-to-end deployment story, what we said is, we're going to create these specialized operations functions that are going to give a set of shared services to you. We're going to provide one set of people that just deal with all of your infrastructure operations. Like, CoreOS is a great example of really simplifying and sort of commoditizing the basics of OS operations. But we've also added a speciality, which is around cluster operations and giving you the ability to start thinking about the cluster as a common service that everyone can use. And then applications operations is often initially just a function of the developer. It looks like DevOps, but you don't have to worry about like that whole line all the way through to the physical machine. Your responsibility ends where the cluster starts. It's a very powerful thing. The other thing we got from this, obviously, is the ability to produce much more complex systems and run them with fewer bad outcomes, right? So the incredibly terrifying moment of actually pushing a configuration change or an update to a very, sort of complex system, that's the point of terror for everybody, right? Like that's when bad stuff happens. And by creating these deeply automated systems, we were able to do that in a far, far more controlled way. We could like canary things. We could push out something, just trickle a little bit of traffic into it, see how it worked, like measure the behavior and the experience around that, make decisions to roll that back or kind of roll it forwards. And all of that was deterministically handled. And so getting into this new cloud-native computing world gave us this almost assembly line-like capability to just deal with things, far more precision. Everything is exactly as it should be. With much better degrees of control around how things get rolled out. And then the other piece of this is obvious resource efficiency. We moved from a world where, and actually, the best way to explain this is, I've actually worked on two kind of distinct product lines in my life, right? The first product line I worked on was a traditional virtual machine-based product line. And the second product line was bringing this cloud-native computing paradigm to developers everywhere. And one of the most fascinating experiences that we had when we were working on Compute Engine were a set of conversations we'd have with our resource planners, right? because we had produced this beautiful, pristine physical infrastructure that we were selling to our customers, and we were carving up machines into these nice tracks of computational resource. You get great network characteristics, great storage, and everything was great. And the guys it was obviously running on the same basic infrastructure that everything else was. So all this was based on the Borg technology as a scheduler. And we'd talk to our resource planners, and they'd be like, and we're like, we need more resource. We've sold all of our VMs. And they were like, no, you haven't. Like, look at the amount of the actual physical machines that people are using, because we had a decent set of controls around what's being used. And we're like, no, we've sold it all. It's all, we're completely out of inventory. But and you'd have to explain to them that this basic model was that we're just selling the ability to compute. We weren't actually necessarily trying to carve up the entire machine. And it was a jarring disconnect. Like, the level of efficiencies that our traditional VM-based customers could get out of a given virtual machine, the amount of that machine that they were paying for that they could physically use, was disproportionately low compared to what we could actually get out of our mainstream fleet that was being managed by Borg. And so I expect that for enterprises that are cost sensitive, not every enterprise is highly cost sensitive, but like when you're talking about several integer multiples, like many integer multiples, more efficiency, it really starts to make a difference, particularly if you don't have to give up quality of service. Particularly if it comes with radically reduced operations overhead as well. So this is all goodness. So in getting from where we were 10 years ago, when we had these overstressed pipelines and everyone was crazy and the SRE team was incredibly twitchy, to where we are, we had to build a few things, right? This wasn't a small amount of work to get here. The first thing we had to build was like container technologies. In fact, a lot of the work that has happened today in the container space is based on the original Google C Groups work that gave resource isolation to groups of processes in the Linux kernel. And we pushed that as open source because it was kind of lonely working on this technology. We were trying to explain why we wanted a lot of upstream kernel changes. And it was pretty clear that it was going to be a lot easier to explain if we just contributed the technology as open source. And so that kind of kicked the ball rolling. But beyond that, we've had to build a lot of stuff. Like, we had to build a scheduler. In fact, we built two. We built Borg, and then we built a successor, Omega. And now we're working on the third generation of that, which is called Kubernetes. We need to build microservices frameworks, efficient RPC frameworks, CI/CD, a lot of other pieces. And it turns out we weren't the only people doing this, right? If you actually go and look at the other folks, there's an amazing amount of coevolution happening. Facebook had built the same basic things. They just called them different names. Twitter was working on the same set of things. All of these internet companies had co-evolved the same basic pattern: container-based, dynamically scheduled, microservice-oriented architectures. But they'd all been doing it. So, what could have been called Jiffy, as Alex pointed out, could also be Fiffy or Tiffy or Niffy or Iffy or whatever, right? Like, this exists in so many different forms. And you could go and do this yourself, right? Like, there's nothing stopping you doing this. In fact, you're probably at a point where you're starting to deal with internet scale challenges yourself. IoT is happening. It's generating insane volumes of potential data. The ability to actually derive insight from new data streams generated by a mobile customer base is going to be a key differentiator in terms of serving your customers. So you're getting to a point where you're probably starting to feel a bit like an internet company, one way or the other, and you could absolutely go off and generate your own, IFI, like, pick the first letter. But you probably don't want to, right? Like, it's actually quite a lot of work. And getting to the point where you're actually operating at true scale, like, will take you down some interesting roads. And when you start looking at it, obviously, you're going to need more than just containers. And I hope this is becoming obvious to you right now, right? Like, containers are going to get you, a first step down the road. They're going to solve a lot of gnarly operational problems for you. But the more time you spend looking at it, you're going to discover that Docker's going to give you an amazing first 5 hours. It's going to create this amazing and insanely awesome bootstrapping process. It's going to get you, a really nice way to get that into production. But when you start to think about the evolution of your application, when you think about the next 5 years, when you think about the set of investments you're going to have to make to maintain that application to be aligned with the set of business processes that you have, and from an operations perspective, what you're doing in that initial development phase, pales in comparison. I implore you to think about the holistic story, all of the pieces you need, of which containers are one part, schedules is another part, but there's a whole bunch of other technologies that we need to rally together as a community and really build out. So what was our answer to this from the Google side of the house? When we're thinking about this, there was clearly this big gap, which is around the scheduler. So we're like, well, you need a cluster manager. Containers are great, but you are going to need a cluster manager. We should build one for you, and we should just give it away as open source, right? That was the answer. And so Kubernetes was born. This is a cluster manager. If you haven't heard about it, it's oriented around Docker or Rocket containers. It's built in the open, and it is a product that is really focused on bringing our view of cluster sort of first development to the world. It's simple, it's modular, extensible, and it's really intended to be something that you can take, make your own, extend, and sort of, we were hoping to build an ecosystem around it. So we're crazy, right? Why would we do this? What were we thinking? In fact, I had conversations with my management where they said, those words, you are crazy. Why would we ever do this? This has been a huge part of Google's success. This has been central to our ability to actually function as an internet company. Why would we just give away that intellectual property? Why would we just give it to the community? And the answer is, turns out we're an infrastructure company. We actually do infrastructure really well. We have an incredibly refined process of actually getting and providing and delivering high-quality infrastructure to you as a company. And the way we want to get there is not by just trying to replicate an existing set of patterns for management. We could do that. But what's far more interesting is to bring our way of thinking about infrastructure management and deploying applications into infrastructure to market, because it turns out our infrastructure is really optimized around this workload. It does a great job of supporting precisely this workload. It's been built for a decade to really nail this workload. So you could run this technology anywhere. You could absolutely, and I encourage you to go and try this on Amazon. I encourage you to run it on OpenStack, or pick the environment you want to. We've worked very hard to make sure that Kubernetes works everywhere, just as Docker works everywhere. But the question in the end is that what you're going to want to do? Our hope is that over time you'll discover that turns out these Google guys are pretty open, and they've actually created a hosted product called Google Container Engine, which has a sort of slightly different logo to Kubernetes, that offers a hosted alternative. So, just as Jonathan explained Intel's interest in this space, this is our interest. We want to move the world forwards, and we want to provide a very natural and open way for you to try this technology on our basic infrastructure. And we'd like to also, at the same time, help you navigate the world a little bit. We've made a lot of mistakes, and we've actually made some great design decisions. And I'll give you just a couple of examples. I don't want to spend too much time getting into the technical detail of Kubernetes. There's a lot of good material out there, and we're always happy to talk about it. But some of the core design decisions we made were not accidental. These were based on some long, hard experience, right? So I look back on my childhood, and I think about some of the things that weren't obvious to me at the time, but became obvious later, 220-volt sockets. They had protectors, so you couldn't stick stuff in. It wasn't obvious to me when I was very young why they did that. I soon learned out, right? There's some things that when you actually, you spend enough time and you try something and you make a mistake, you'll learn that way. And most of what Kubernetes is about bringing our experiences to market. So let me give you a sort of a starting example. We tend to structure containers not as a single entity, but we tend to deliver them as a collection. It's been an incredibly important part of the way that Google operates, right? So we won't just package something up and treat the container as a semantic equivalent of a virtual machine. We intend to think about a container as an atom of deployment, but you tend to want to build these molecules of deployment, these coexisting entities that you deploy together. And a great example of this is if you're doing something that's serving web traffic and it has some kind of logs processing or data updating component to it, you don't necessarily want those things to be running in exactly the same container. You want them to be running in separate containers so that you can co-schedule them. They can have access to the same basic resources. They can have a shared existence. And you want to be able to version them independently. You want to make sure that the thing that is serving web traffic is running at a higher priority than the thing that is actually doing logs rolling or a data shard update. Because if you do that, you can actually pack far more of these things together. You don't have to create as much slack so that the log roller doesn't inadvertently consume resources that could be used to serve traffic. But more importantly, you also want to put these things behind, create them as a directly addressable entity. We in our early days of Google, we were using these patterns but we were doing a lot of port mapping. So we would actually try to get these things, and then we wouldn't actually put a pod behind a given IP address, and we would instead try to do some port wrangling to make it all work. And it creates this horribly complicated system. As these entities dynamically kind of come and go, and as you have to kind of co-schedule them with other pieces. So part of the Kubernetes decisions, the design decisions we made very early on was, the basic atom of deployment is a pod. Containers are not VMs. You need to co-schedule them together. And by goodness, give that thing an independent IP address. It makes a ton of sense. Another thing we learned the hard way, one of the very first things that happened once we had solved that kind of, that leaky water main problem that, 10 years back, and introduced a more modern way to actually run production services is our developers produced a whole lot more production services, like a whole lot more. And it quickly became clear to us that there was no practical way to actually organize and reason about the sort of wealth of services that were being generated. The only thing that really worked for us, and we tried a lot of different things. We tried hierarchical management and a number of other sort of models of reasoning about the set of services and applications that were being deployed into production, was to provide the ability to add arbitrary labels and manage through labels. Letting people make sense of the systems according to their own terms, and then being able to link those systems to the actual orchestrators so that something under management achieved semantic meaning because it was labeled as such by the actual person who's providing it. And this is another great example of something we really struggled with. It's not obvious until you start trying to run massive numbers of production services, until you actually experience that incredible productivity that container technologies bring to market, that this is important. Another example of this, the replication controller. This is another intrinsic piece of Kubernetes. We quickly discovered that linking control, or trying to centralize control didn't make a tremendous amount of sense. It does make sense to provide a central control plane, but if you're making individual momentary control decisions from a central perspective, it just doesn't scale all that effectively. A pattern that worked incredibly well for us was creating this idea of a discrete controller that could be imperatively programmed to achieve a certain outcome for a subsystem. So breaking the control problem down into this more federated system, creating a declarative mechanism that could program discrete controllers, linking those controllers in a very intimate way to the things that they're controlling, and creating strong control loops changed the game for us. It may not be obvious to you, but this is a pattern that's really worked for us, and it's worked very well in production at scale. And then finally, this one's kind of obvious, and I don't need to spend a lot of time trying to sell you on the idea of being able to actually provide a atom of encapsulation and basic consumption around this microservice, making it easy to tear your application apart at a moment's notice into smaller pieces, stitch them together, make it really easy and accessible to consume them. And then the ability to actually start promoting some of those microservices into common shared services that you might want to use with common semantics is incredibly powerful from an operating pattern. And this is basically the same slide that I think a lot of people during the day are going to show, right? So it's like, oh, great, that's awesome. You've spent a lot of time, you've helped build the community. We're done, right? No, we're not done. We're not even close to done, right? This is a diagram that I've been using a fair bit as we've started to kind of pull together this cloud native computing foundation and really try to pull together the ecosystem. And when I look at it, there's a lot here. Containers show up. The container runtime, which is really being driven by OCI, is that one small green box. But you need so much more to actually build and operate a container-based system at scale, right? You really need to start thinking about application definition and orchestration. You need a common service definition that lets you stand up and tear down services in a variety of environments. You really need a set of common distributed system services. When you think about it, it's embarrassing that today, the experience when you go to scale something out, if you're running it in a single node, it's really easy to fork exec and get additional processor resources. You get to the point where you run out of physical resource in a given machine, and then you have to break out and go and speak to a cluster manager and try to provision additional resource. If you want to run something that requires quoruming, you have to deploy, you either have to stand up and run something like etcd, which is actually a great technology, or Zookeeper, or you have to implement, sort of RAF protocol or Paxos or something like that. It's embarrassing that we don't have a standard service definition that supports this. etcd is moving us in that direction. We really need to start thinking about what are those standard set of system services that you can always bet on. And how do we actually mark up the dependencies of a given container, saying it actually requires the set of services, it has the set of dependencies. And then you think about container distribution. There's a lot of other, things that you're going to need to actually create a safe repository for your containers and be able to find them and discover them and index them and establish provenance around them. And all of this is crying out to be standardized. And the important part here is not just standardizing the atom and picking this is the one runtime thing to rule them all, or this is the one scheduler to rule them all. It's not about that. It's about establishing a set of standard interfaces so that we can start pulling together systems that make sense for people for a given need, and the ability to actually create safe specialization around some of these stacks. And so when I think about it, standardization is critical to creating a vibrant ecosystem. Closed ecosystems that are locked in and don't have clear standardization points are not as vibrant. We need to create the opportunity for someone, a startup or an enterprise company or something else, to safely specialize and say, look, you know what I'm going to do? I'm just going to solve this one part of the stack. I'm not going to try to build a whole stack that's tightly integrated. But I can rely on these interfaces that have, they're well-defined, they have strong semantic consistency, and they exist everywhere so that I don't have to implement and qualify a whole stack. I can just focus on the CI/CD integration parts because I have a well-defined interface to a scheduler. Or I can just focus on the container distribution because we have a well-defined interface between the thing that vends a container and the thing that consumes a container. And so as we think about where we're going as a community, we really need to build the whole stack. And that's a big part of what the next part of our journey is. I look at things like Docker, or I look at things like Kubernetes, I look at things like etcd, I look at the basic OS. All of these are important parts. We need to now start bringing them together and telling the story. And the way to do that is, at the output of this, we want something. We want things that are as ubiquitous as the Linux kernel. We want to get to that point. And a big part of that is why we've been, as a community, focused on creating a new foundation to actually drive a lot of these technologies. And so the intent here is to assemble a harmonized set of technologies to establish standard through code rather than spec. So the intent is not to try to create the these sort of big, top-heavy specifications and then expect people to implement those specifications. The intent is to find working code that's solving real problems today that people like, pull it together, and then use that to actually establish the semantic standard and then promote that API to be the API standard. And that's what this organization is all about. And it's intended to be a place to identify and start filling gaps with a very strong community component. Our desire is to not just get there by coming in from a top-down perspective. We want to create an empowered organization that has a very strong end-user sort of part. We want to make sure that the people who are using the code are as well represented as the vendors. And we want to create a strong technical oversight function so that the foundation isn't balkanized, doesn't get pulled by the vendors into a bunch of different pieces. And this is a bold vision. One of the things that I'm really excited about is just the level of sort of engagement and participation we're seeing. So you've seen the slide earlier in terms of the set of people that are rallying behind this Cloud Native Computing Foundation. And you're going to start seeing a lot more press and a lot more announcements and a lot more energy around this. And some of these folks are, we've obviously been working together as a community for a while. A lot of this that's sort of being pulled together is about empowering the end users to do this. So one of the things I just wanted to give a little shout out about is Intel's actually donating like $15 million of gear that'll be dedicated to this foundation. So we will have like a 1,000-node cluster that we can offer up to the community and partition out and let people use to actually start running these workloads, experimenting, really getting that kind of end user component. And so a lot of folks are really stepping up and bringing a lot of resources to the table, and we will continue as a community to sort of advance these technologies. So with that, I just wanted to say thank you and pause, and I think I have time for one question, since I have like 57 seconds left. All right, one question.
You said earlier that Google is an infrastructure company. Do you now think of it as entirely an infrastructure company, or do you think of it kind of internally as infrastructure on this side and development on that side?
So that's a great question. I said Google is an infrastructure company. Clearly, Google is not just an infrastructure company. Google is an internet company. It's an advertising company. It's a consumer web company. It's a lot of things. It is absolutely all of those things The key thing that we're doing now is really starting to build an enterprise business that's grounded in a very high-quality set of infrastructure. And the thing I'm excited about is we have amazing capabilities in the infrastructure delivery space that we're looking to use as a foundation for that broader business. I don't know if that answered it perfectly, but there we go. All right, I am precisely out of time. So thank you, folks. Sorry, one more. Okay, we can catch up later.